Well, hi guys and girls, Emma again. Welcome back to the spare room. Welcome back to the next video in this little build. This is the Stuart Progress, and fairly straightforward little oscillating engine. Last time we got this cylinder machined, ends machined, board ported, valve face finished, looking pretty tidy. This time we're going to make some end caps. Now, we've got these two crappy little castings, which by definition, they're awesome with a kit and they look great. And if you mess around with them, you get good results with them. But generally, cylinder end cap castings are way better made out of a solid bar than messing around with castings. But these are savable, so we're going to do that because they come with the kit. I've taken some time and machined these two filing buttons. They're just out of ordinary steel. They're very, very basic. All I did was machine a piece of stock to the right diameter. And by right diameter, I mean the diameter of your finished cylinder caps, which is 1.8" by the book, less the thickness of, twice the thickness of your cylinder cladding, which goes around like that. So they're done. They're only fairly soft stuff. I reckon this is probably 10-20 or something like that. It's just a piece of bar I had in the drawer. Next job is to case harden these. We're going to do those now, and then we'll have a couple of filing buttons that we can actually use accurately to make the cylinder the right size. So got some cherry red case hardening compound. The rain's just starting here again, and a little braising heart, braised steak and onion tin, this stuff's fairly expensive, so you don't really want to be too wasteful with it, because you throw it out, you don't put it back in the jar, or everything goes sticky and slimy and awful, just from experience. So I only really want enough to cover the tin, because with these, the only surface that needs to be hard is this one out here. So if we get these red hot and drop them in there and turn and kick them around in there a bit, and pull them out again with a pair of pliers and get them red hot again and quench them in water, we should have nice case hardening. So, not sure how many people have seen this. This is not casing it, which is cyanide sort of based, and is fairly poisonous, treacherous stuff, but it's cherry red and it seems to be, the theory is it's non-toxic, but don't do this inside, and if you do, make sure you got the fan going and all the doors open. So we've got 2 case hardened pile buttons there that should be plenty good enough to make it up. This material here is not much good for anything once we're done. So toss the tin and everything. Use a disposable tin. Toss the lot. Unless you've got something else to case harden in the next 10 minutes. If you've got a few things lined up, well, get in and do the lot. But toss this because it's noxious on the wall, sitting around on the workbench, and the best thing is just to push the sides of the tin in so you don't feel like you want to use it again. And toss it in a bin. This should nicely fit in here. If we put a clamp on these, or even just hold them together, the easiest way to clean this main up here is on the linisher. So I'm just going to go over there and I'm going to give these a good clean up. And when I get them somewhere near close, I'm going to hit them with a file. So no matter what happens, you're going to get black from cast iron. So especially handwork. What I've done is made this something more like the drawings say they should. I've put a line along here and a line along here, and I've machined it down so that these pieces that were sticking out here square are smooth right down to the tapered down there nicely, so that when we wrap our cladding around and put 2 screws in here and the 2 screws in here, everything's going to sit nicely, and there's not going to be too many compound bends in there that is going to be impossible to clean up. And also, this is now the right width here for this pretty much. It's not quite, it's a bit wider than it needs to be, which doesn't hurt, but that looks like it's going to be pretty good. It's a much neater fit on there now. So that's what I've done. Is these 2 little castings. Now, the book says that these have got spigots on them for gripping them, and they sort of have. They're also sort of terrible. This one's nowhere near in the middle, and I'm not going to use that one. This one's sort of in the middle, but there's no real point in using this one either. They need to be 1/8" diameter, and they need to be 332 thick on the flange, and then they need to be a little bit thinner on the inside. If we look at the book, this says 32nd full, which is the thickness there. Now, what does that mean on old drawing? 32nd full. Probably it's a measurement that needs to be checked and measured. So if we make this step here of 32nd, the best way is just to machine the face and then move your compound in 32nd and machine them again. It's the easiest way to measure. If you've got a DRO, that's great too. They need to be 1/8" diameter. The flange is 332 thick, and this sticks out the end here. Now, there is no dimension about how far the flange sticks out, so it wants as much as it can on the casting. I think I'm just going to clean it up. It's a bit of a... we're going to have to calculate that out, I think. Going to make a little gland for it, which looks like this. But the best thing we can probably do is see how it turns out. So we'll start with the easy one, which is the front one. Going to see how that grips up there and how it runs on that spindle in the middle. It wants to be pretty nice, and if we can get this running, I think this cone in here is concentric to the outside here. So if we can get this outside running fairly nice and grip that, then we can face the back of it and machine it down. And then there's only 1/32, so we can't really grip it on the flange, but there'll be a way to grip it so we can clean up the inside, I think, or the outside. So over the lathe. So I've set this up And it's running reasonably true here on the cone, and on this piece here I've just gripped this in the 3-jaw, and I've put a block behind it just to see how it looks, and it's not far out. If we move this tool back in here, the clearance this way is pretty good on the front, so there's no actual taper in the pattern. There's very little end shake or side shake when they've taken the pattern out of the draft, which probably means they've been done on a matchboard. But this piece in the front here, which was supposed to, according to the design, set this up to clean it, to clean up the back, I don't think it's going to clean up particularly well. We might just try it and see. So the reality is, you haven't got a hope. I've tried a centre hold in there, and the reality is you haven't got a hope of holding this by that little stem. Stuart, if you're watching this, that's something that could definitely be improved out of sight. It's a really crappy engine design part there, that a crappy design that there's no way in the world you can cast that. So what's next? There's plenty of meat in this casting. So at 332 and a 32nd, it only needs to be 8 thick, and it's about 1/4 inch thick there. So there's plenty of meat. I don't really want to hold this right on the outside and machine this and then turn it around and hold it on the boss for that goes in the cylinder. I really don't want to do that. So probably if you had a decent 1/2 inch collet system, you might be able to do that. Don't like it much. It's going to move, it's going to come out. It's only holding by 30th thou. So what I think I'm probably going to do is set this up this way, right? Live with it. Whatever this happens on the back, we'll just machine it concentric afterwards. Get this somewhere near, put a decent land on this, down to the right diameter, and 1/2 inch boss, so that it's got 1/8 of an inch or more to grip on. So in the end, right, I've had a good think about this, and the best thing that we can do, there's plenty of meat left on this casting, there's plenty of iron in it. I've machined this down so there's quite a land, but it's still oversized here, which means that we're going to have to set it up again, but it's not a big deal, because by the time we get to that point it's going to be concentric. So I've taken this down. There's still, if we have a look with a caliper, still well over, it's about 5/32 of an inch, so it still needs 1/16 of an inch off it or something there, but there's enough there that we can grip this comfortably on this boss. This is oversized, so we still need to machine it to size later, but we can now turn this around, right, and grip this like this. Clean up the outside, take that boss off the center, give him all a nice clean up, and get it to size. And to get this down to 1 1/8, and it's still well over 1 1/4 there. I think that's probably very, very close. Let's check that. Probably a couple of thou under, and if we make the other one like probably 5 thou under, if that, 2 thou maybe. If we make the other one the same, then we'll end up with a very similar sort of situation. Now, this flange here needs to be equal distance each side of the PCD. That sounds like gobbledygook, but there's a line around there that the bolt holes are all positioned on, which according to the book is 7/8 of an inch diameter. Now this is 1 1/8, which means 1/8 of an inch each side. Now to get this flange here, or the flat surface, equidistant across the PCD to make it look good, that means that the center boss here needs to be 1/4 of an inch smaller than the PCD, so 7/8, 5/8 it needs to be. So the best thing to do would be to machine that now, flat across there and down to 5/8 in the middle, and then we can shape up the outside. There's 680 there, and it needs to be 625. That's 55 thousandths of an inch. convert that to metric, and we're about 1.4 millimeters, something like that. Half of that on this hand wheel, because this is on the diameter, on the radius, not the diameter. 1.4 is 0.7. And I'm probably just going to file this, hit this with a file. A graver is probably the nicest way to do this, just on a graver rest, but I don't have one for this lathe. So I'm probably going to hit this to a file till it's a profile that I really like. You could make a form tool for it. That'd be nice too. Doesn't need maybe to be that precise, but as long as it's a good finish and a reasonably good shape. We can very carefully put a little dome on there very easily, and we'll give him a bit of a clean up just with our fingers. We know what that measurement is, so it's fairly easy to wind this into where it was, which is and just kiss that to clean it up again after we've filed it. That's the front of our cover done. Now we need to set it up on here. Same deal, couple of parallels, get it all nice, set it up this way around in the chuck, and just grip in there, and we're going to clean this up and clean this up, clean this off here, and call this cover just about done. Now, if you haven't got quite the right parallels, a piece of high-speed steel is really good. It's probably not a real bad idea, and I had sort of thought I probably would make one, just to make a little cylinder out of steel with it doesn't even need to be a cylinder, it's just got to have a recess in it so that it clears the middle piece and it's the right length and it's less smaller diameter, and then you can set that up nicely against there very, very simply. It's probably, if you have a look in your scrap box, you might have something that fits just nicely. So if we do that up, and that's running pretty true, I think we can take most of this off, and still 25 thou too thick. So set this up nicely with parallel behind it just the same, and we're just going to clean this up, and we need to put a shoulder here. Suspicious that this boss on the end wants to be a bit longer rather than a little bit shorter. That's where I'm at with that. So probably what we want to do is take a bit more off the, this is nicely in the middle, it's taking the same amount off each side. We want to take a bit more off the front than off the back, perhaps. Really not sure, maybe that is enough to clean up. I'm going to take this down to measure it the same. This needs to be the same diameter as the other one on the front, which is 5/8. It still needs, what, 35 thousandths of an inch off it. That's about 0.9 of a millimeter. So that gives us a nice clean up on there, and it gives us very, very similar on each side. So like that, I think we've got this somewhere near the middle. We're going to file it up a bit afterwards, but it's not in the middle this way, it's a bit ugly. Anyway, we can take a lot of this off here too. We're not going to set anything up on there. We can do a little bit of clean up on the outside too, I think won't hurt it. Next job is to drill this. If we come over here and have a bit of a look at the book, there's not much information. What we've got is a piece of 1/8 rod for the piston rod. So I guess the gland needs to be 1/8 to match. There's nothing written here really. It says that it needs to be 1/4 inch, so this says 1/4 inch here, and 732 long, and 332 there for this gland. These here are the piston and valve spindle glands for the other engine, so not much use to us. But we do know that this needs to be 1/4 inch, and it needs to be probably about, look, we're really guessing this because it needs to be as deep as it possibly can, but it doesn't want to break through. Most of the wear is actually going to happen in the gland, or most of the work is going to happen in the gland. This one's just a hole to guide it. But there's not much gap there. It's about 1/16 of an inch. So probably the best thing is to drill it and ream it through 1/8, and then clean the outside out to 1/4, and then we're going to make a mandrel up to mount it on to machine the back. So it's not a bad idea to grab a micrometer at this stage and actually check to see if this is 1/8. It may have supplied 3mm, but they haven't. It's 0.125 thousandths of an inch, so that's something. Got a couple of 1/8 reamers there. I've got a twist one and I've got a straight one, and a 1/4 inch drill to house the valve rod gland. And this is what we've got. We've got a pretty nice slide and fit there. So next job, make a mandrel to fit this, which needs to be 1/4 turned down to 1/8 with a nut on it. Before I do that though, I'm going to chuck this in the lathe, and I'm going to machine this down. Only needs to be 1/8 of an inch thick, something like that. So I'm going to take a fair bit off it, down to the right thickness, and then when we put the nut on it, we won't have to touch that face again while we machine the rest. So in the center, we're down to the right thickness. On the outside I'm not, because I run into the jaws if I don't, my new chuck, and I don't want to do that. So I've left a little bit of a taper in the back here, and it doesn't matter because we'll take it off later. But this thickness in the middle is where it needs to be. This looks really good. This is 1/8 here in the center. So I did that by measuring the outside and measuring the distance here on the outside, and cutting that in till it was the right distance there on the hand wheel. Now, the thing about this is, we're not going to touch this again, and yes, I've just set it up so it could be wobbly. It doesn't matter, right? It shouldn't be bad enough to be a problem, and it really doesn't matter, because we're going to set this up on a mandrel with a nut here and machine the outside, so it's going to be concentric and square and smooth to that hole. This surface here that the piston bangs up against or comes in close to isn't going to matter very much what that's like, because it doesn't have any bearing at all on the alignment of this spindle to the cylinder, so that really doesn't matter. This is a bit ugly, and I'm going to give this a good clean up here nicely. It wants a bit off here and a little bit more off here. Just some work with some fine files a bit later on. But at this point, we need to make a mandrel, and this could have been a little bit deeper because we've got some porosity there, but I don't think it's going to worry anyone. Make up a mandrel, screw this on, and then we're going to machine the outside in this step, and we'll have this particular cover down to the level that the other one is as well. So this needs to be a bit of, needs to be a reasonably good fit, a pretty good fit. I'm going to take a bit of care with this. 6.62. Also, once this is in the chuck, we don't want to take it out again until we're done with it. So take a bit of time, get it right. If you muck it up, do it again. That's fairly important. And that's a pretty good fit. So what we've got the cover on there, which is how it should be. It clears here nicely where I think it needs to be. This one's the same. See, we've taken this off here and here, down to that width to match the valve port on here, more or less. Not quite, but getting that way. This one we've got done too. I've made a mandrel, which looks something like this, to basically true that up on the back with a nut and a washer. Next thing is this crappy little casting here for the gland. Seriously, it's still got flashing on it. All things considered, it's probably not a bad casting. It's a rotten thing to hold or set up. It's a pretty nice shape compared to this gland here, but it's way too big. So how do we do this? First thing is to give it a touch on the linisher and just clean the flashing off here. And we'll make a jig and we'll set him up, and I'll show you how to machine that nicely. So this has got two sides that need to be machined, the same as these. This one needs to be flat, and then we need to set this up, and we need to bore this and machine the outside of it. Machine this down to about the same length, 5/8, and then clean it up with a file. But before we do that, we need to have some sort of way of holding it. So this is actually, compared to these castings, this is pretty good. So the pattern maker is obviously someone who's a bit different, and maybe they're for a different engine, and this is more what I would expect from a Stuart casting. It's nice and square and parallel. Everything looks pretty good. So I'm going to set this up in the 3-jaw. I'm going to face the top just lightly so we've got a surface to work on, and then we're going to make a jig to set it up quick and easy, and turn it around, set him up on this boss, and machine him from that end. So let's have a look at that. Now we need to silver solder, soft solder this onto something to stop it, so that we can grip it. We can set this up in the 4-jaw. Really, we'd like the whole thing sticking out so we can machine it though. And you could do the same. You could put a hole in it and probably put it on a mandrel and then set it up and machine it again in a very similar fashion. But the easiest way is just soft solder this to a piece of brass, and we'll put this in my new faceplate. Could soft solder it to something a bit chunkier and set it up in the 4-jaw without any problems. I've got a thin piece faceplate, a 3-dog faceplate that I'm going to use for this, which is probably the easiest and quickest for me. And I'll solder this to a piece of plate, and we'll see how it looks. So I've soft soldered this to an old brass gear blank that I had kicking around here that didn't work out, and I've set it up in the faceplate. So basically, just with a needle, like such, on a surface block, and got it pretty close. Now this is a casting, right? Don't put your nice indicator on a casting, that's just stupid. because it's going to bump all over the place and it's not going to do it any favours, and it's going to catch and you're going to kick it round sideways, and it's going to, yeah, it really is not a very nice thing to do to an indicator. This has got enough meat on it that if it's within 25 thou, it's going to clean up. There's much more. You can get this much closer than that with just a needle. You can get it within probably 5 thou by eye. So we've done that, and this is all nice and tight. We need a machine down in here past these jaws without running into them, and this tool's really not the answer for that. We can probably get this one done with it without too many problems. It hasn't cleaned up really well on one side, so I'm just going to give this a tap. Way too far there. No, it's probably not far out. And that's trued that up nicely on the base, on the boss there, without any problems. Because this boss needs to be central, not the actual stem on the middle, and they probably didn't line up particularly well on the casting. Looking at this boss on the back only needs to be 332 thick, which is a whole lot thinner than we're going to get with that tool. So I'm going to mess around, try and find a tool that's actually going to work. I've got this down somewhere near. There was a nasty big blowhole in here. There's a picture of this, but it has just cleaned up. I'm still going to have to sweat this off here and turn it around and face the other side, but it's starting to look half reasonable, I think. I would like this to be a little bit longer in the spigot, but not going to happen. That's going to do. So take this off. I'm going to put that in a collet and reverse it just to clean out, just kiss the outside to clean it up. It's another blowhole here that I'm not real happy with, but I think it'll clean up. It's a casting, but I would have much preferred not to have issues like that with this particular casting. I would like some more meat on the back to clean up, and a little bit more length on the front there, but I think that'll do for a bit. So there we go. Probably just going to quench that out, clean it up, clean the solder off him, let this cool off and put that back in the scrap box for next time or something else, and we might just have a bit of a look at it then. Let's clean that up nicely. It's still got a burr on there and there. I'm just going to clean that up with a file. We might just put this back on the cover and see how it looks then, and think about drilling 2 holes in it for screws. So let's have a look at this. What we've got is this little cover. It's hardly long enough in the boss, but it'll do. I think with those 2 in there, and it's a good fit and a bit of string between them, that won't be a bad bearing surface. I would love to see it a bit longer and a bit less packing material, but we can't really choose that. There is another one coming. I've had some feedback from Stuart Models, and they are actually posting a new one out. So hopefully I will get another casting, and I might have another go at this at some point. But until then, that's looking reasonably good. I think that'll be all right. So we've got that on there, and this one here goes on there. All that down to size, looks pretty good. That cladding will just fit beautifully inside there and fasten there. These need some bolt holes in them next, and we can start work on the next piece. So thanks for watching. Don't forget to like and subscribe. Hit me up on Patreon if you want to see more of the Stuart 400 engine, which is a contemporary of this engine, only a much bigger project. And more soon, guys and girls. Be kind to each other.